got a start on this last week, but I have not done much with it yet. Let me point out first number 1 here. Nice. Let's call this y is equal to inverse sine x. And we all know that inverse notation has implications. The function's got to be 1 to 1. And the domain of one switches with the range of the other. All those little items we know about inverse. But here it looks this way. Now, can someone, I realize it's a Monday. I have not seen you for a while. You had a test on Wednesday. Does anyone recall anything about inverse sine x in our discussion? About inverse sine x. Well, were there, Samantha, were there some restrictions made?
As in the domain and range?
Thank you. What was the domain? This is the x, it's the domain.
Domain of sine, the inverse is -1, 1 brackets.
-1 up to 1 only, okay.
And then the range is bracket -pi/2, comma pi/2.
And -pi/2, tell me, up to a +pi/2.
Yeah.
Now, when you see this for the first time, let's say, unless I do a worksheet before I get that final exam out to you, you'll definitely see some of these on the final exam. Guys, all these inverse sine, inverse cosine, inverse tangent, they have restrictions. You have to, I hate to use the word memorize, you got to know the restrictions. So what's going to happen is, with this, and I think I showed you last week why they made these restrictions, I'd like to find the exact value of these expressions. Now, I have some here in my notes. I may call on Sarah to see if she can find some more on that handout. But let me get you started with 1 or 2 here. And that would be, I'll just start you out with inverse sine 1/2. Let's find the exact value of this. Now, here's the translation. I know the definition. This is the definition. And then Samantha gave me the domain and the range of this definition. What it really means, guys, is there's an angle out there whose sine is 1/2. And it's on that unit circle. So first, the translation is this. When you take the sine of that angle, you get 1/2. That's the start. That's the translation. Now, where on that unit circle have you seen, you've already done an exam about this, where have you seen on the unit circle with a y coordinate sine equal to a 1/2 to begin with? 5 or 6. Now, it just so happens, I'll put a comma here for right now. There's another point on the unit circle where the sine is 1/2 besides pi over 6. 5 pi over 6. If I were a student, I would think, well, why not get 2 answers? If you check out the unit circle, those are the only 2 that have for a y coordinate 1/2. Well, that's by this restriction. You can't have 2. It has to be a 1-to-1 function. That's why they're giving me restrictions here. So guys, my answer down here I have it in red. Like Samantha says, it's going to fall between -90 and a +90. We're going to think about degrees. Now, with 30 degrees, fall between -90 and a +90. If so, that's the one I will accept. This one, by the way, if you think about degrees, is 150. And 150 definitely will not fit between -90 and a +90. So the only answer is pi over 6, and that's the only caution, really caution about these inverses. You got to make sure you have the correct answer to fit that restriction. So that one's finished. And I threw in another one here. I sure did. Let's see if I did. I did. Inverse sine. Let's try another one of those. And this time I threw in -1/2. Guys, translation, right here it says there's an angle out there that when you take its sine, or find the sine of it, you get -1/2. Now I'm going to do something with you on this one. First, can anyone tell me where is it located? In which quadrants is there a possible angle whose sine, the y coordinate, is -1/2? Where is sine negative? 3 and 4. So the answer is going to be here or here. We'll do this one on this one. Now, if I check quadrant 3, do it right here, guys. Quadrant 3, the size of the angle, and some of my students may know, does anyone know the size of the angle in quadrant 3 whose y coordinate is -1/2?
-5/6.
like 7 pi over 6? Was it 7 pi over 6, guys?
Yeah.
Now, can you tell me the one in quadrant 4?
11 pi over
11 pi over 6. Now, the reason I brought this in tonight to get you started on these inverses, 11 pi over 6. You say, wait, Professor, just like on that first problem you worked out, I got to make sure these fit the restriction. So in terms of degrees, I'm talking about, I guess, 210 degrees and 330. If I go back and say, does that fit between negative 90 and a positive 90? Neither one do.
Well, what about
over 6?
Oh, wait, but the way it's written, do either one of those fit between a negative 90 and a positive 90?
no?
No. It's true that they, on the unit circle, there it is, yeah, but they don't fit. You say, wait, hold on though. I'm sure there's gonna be an answer, and I think I heard the answer coming out. These two right now, guys, do not work. Well, not work. But at least this one is in quadrant 4. Isn't it? 11 pi over 6, so what we do, and you gotta be very careful with this. 11 pi over 6, 330 degrees, sketched, terminates in quadrant 4. Its reference angle is, I'm gonna use radians, is 30 degrees, pi over 6. So what do we do to make an answer come out? We rename that one that's in quadrant 4, 11 pi over 6, we rename it as a negative angle. Lisa, I think you said that at the very beginning. It's negative pi over 6. So guys, if I rename this right here as negative pi over 6, and accept this as an answer now, let's see if I can accept it. Negative pi over 6, that's negative 30 degrees. Now, would negative 30 fit between negative 90 and a positive 90? You can line them up.
Yeah.
So negative pi over 6 is the answer. Now, I see heads looking right now, so Professor, you mean sometimes I'll get something that works, even though it works, I can't accept it, because it does not fit the restriction. Make sense, guys? It's all because of this one-to-one business here. And try another one here, number 3. Inverse sine. Let's write negative. Let's try over there, square root 2 over 2, I guess. Translation, there's an angle out there, and when you find the sine, you get this.
Pi over 3.
Okay. And I would think, well, Professor, I've seen radical 2 over 2, I think as a y coordinate before. I did give it, David, I give you a negative here. So sine is negative, as we said earlier, quadrant what? 3 and quadrant 4 for the possible quadrants here. That's where sine's negative. And I think we've seen, as you glance at the unit circle, what, like a pi over 4 involved here, 45 degrees? Okay, so guys, I say 45 degrees, and it's negative. Now, if it's negative, what size angle went down in quadrant 3, for an example? What is it, 5 pi over 4? Here we go. That one's in quadrant 3. And the one in quadrant 4, check and see if I have this correct, is at 7 pi over 4.
Yeah.
Both those have for a y coordinate sine negative radical 2 over 2. And again, it's a case where do they fit in the restriction?
No.
And neither one will.
Negative pi over 4.
There you go. We got to rename something here so that when in quadrant 4, I could rename it. And by the way, guys, it's 315 degrees. 7 pi over 4 like this. A little reference angle of pi over 4, 45 degrees. And therefore, I could rename it as moving clockwise, negative, in that direction, and rename this as, I'll put it on the side here, negative pi over 4. Which now will fit, that's negative 45 degrees, will fall between negative 90 and a positive 90, and therefore the final answer with all that thought is that. Does that make sense? I mean, you gotta be really, really, really careful. Which quadrant are you located? And if it's not located there, can I locate it? Sometimes there's no solution. I don't have a no solution up here yet. But you gotta keep searching, keep searching, keep searching, see if you rename or find the answer, and it's gotta fit that restriction. Okay? Yes, Samantha?
What if like, okay, so for, this is like regarding like a no solution
Okay.
thing. So what if you gave us like the inverse sine of like 2?
Oh, that's exactly what I was thinking of as an example. Perfect. Translation says there's an angle out there that if you take its sine, you get 2. Now, has anyone ever seen on the unit circle a y coordinate, that's what sine is, equivalent to 2? No. Nor will you ever. So this is a no solution for sure. Exactly right. Okay, guys? Mr. Park, if I gave, I'm doing a lot of work here with the inverse sine. I haven't even mentioned inverse cosine yet. We squeeze in number 5 here. Have all this on one side of the board. Number 5, if I saw this, inverse sine, say 1/5. Is there an answer? Or should I say no solution again? I got a 1/5. It's not one of those numbers you recognize. But inverse sine 1/5, does it exist at least?
Yeah.
Or is it a no solution? Well, the domain way back here, a student gave me is what? The number inside this is called fall between what? -1 and a +1. So inside here for my domain, does 1/5 fall between -1 and a +1? So there's an answer. I just so happens we can't find it. Park could, with a calculator of some sort. Mr. Park, could you find inverse sine 1/5 for me real quickly?
11.54.
Oh, you got it in degrees.
145
something degrees?
No, 11.54.
11.54. Put the approximate symbol here. 11.54 degrees. Now you could convert that to radians easily. So there's an angle there. Now, Abe, all the math I had, you think I could stand here and say, oh, it's 11.54? No way. No way. But it does exist. So guys, make sure you see the contrast here between no solution and one that does have a solution that's not on the unit circle, that still exists.
Would you ever give us a problem like that? Or no?
Like what? Oh, no, like this?
Yeah.
No way. No, unless you were using a calculator. Absolutely. Hey guys, I'm gonna introduce the other 2 remaining ones. Number 2, let's now look at y is equal to inverse cosine x. And the domain here, this is my domain on the inverse.
From 0 to 5?
Be careful, it's -1 to 1 for the domain. And Samantha, what's the y, which is a range?
0, pi.
There you go. That's the trouble with these inverses. There's restrictions here. You gotta make sure you fit the restriction. Now for a few examples, just to see what we are talking about here, let's do inverse cosine 1/2. Translation, there's an angle out there, and when you take its cosine, you get 1/2. Now possibilities are, where have you seen the x coordinate now? This is cosine. The x coordinate is equal to 1/2. Where have you seen it? And that is on the unit circle. Where? 5/3 is a possibility. That's a positive 1/2. And where else is cosine positive besides the first quadrant? Fourth quadrant. And what's the size of the angle down in fourth quadrant? Is it 5/3? 300 degrees? So those are the 2 possibilities. Now, let's see if it makes sense. The answer they're looking for though, that's why I put this in red, it's gotta fall between 0 and pi, by restriction. Does this one, which is like 300, does it fall between 0 and pi? No, so that's marked out. And you're down to one answer, which is like 60 degrees, which definitely falls between 0 and pi, and you're finished.
How would I know 5 pi over 3 is the other one? I just didn't know that. Just one.
What's that now?
How would I know 5 pi over 3?
You better know the unit circle, it's on the unit circle. Okay, number 2, inverse cosine, 8 9. I understand exactly why you're concerned there about that, but make sure you understand the unit circle, or know the unit circle. Guys, this one says negative 1/2, translation, yes. There's an angle out there if we can find it, equal to a negative 1/2. Now, let me point out first where the quadrants, or what quadrants are possible where cosine is negative. Guys, help me.
Second and third.
Thank you, quadrant 2, second right, quadrant 3.
It's 2/3 amount.
Now, yeah, if you go to quadrant 2 on the unit circle, you'll find it's what, 2 pi over 3? Here we go. If I should move on into quadrant 4, and I'm trying to think myself what it looks like over in quadrant 4, guys, what is it?
4 pi over 3.
4 pi over 3,
Oh,
was it?
quadrant 4?
How much was it?
You mean
In quadrant 3.
4 pi over 3.
4 pi over 3. Quadrant 4, quadrant 3. Guys, this is like what, 120, and this is like what, 240? Is that true? 120 and 240. Now, if one of those fits this, I'm done. Does like this one, this is 120. Is 120 caught between 0 and 180?
Yeah.
Yeah.
Of course it is. This one, 4 pi over 3, I think was, what, was 240? And 240 would not fit here. So this one has an answer, it's 2 pi over 3. Now when you do finally see these, either on a worksheet, which we may create and have you work on, for a few points, or on the final exam, it's going to be sad if you're not very, very careful here. Sad that you really know what you're doing, but you've chosen the wrong one. It's got to fit this restriction. Inverse sine's got to fit this restriction. And inverse tan has a restriction. Inverse secant has a restriction. Inverse cosecant, inverse cotangent. I'm doing the 3 primary ones. So this is a glimpse of inverse cosine. Samantha.
Is this chapter gonna be like a lot of the final exam?
A lot what now?
Of the final exam?
It's going to be a big chunk of it because there's a lot of formulas in chapter 6 that we've got to cover.
Okay.
Okay? I'll let you know. Make sense, guys? Okay, now, let me try one more here. Number 3. Inverse cosine. Let's try this one. Negative 1. Translation. There's an angle out there, theta, that when you find its cosine, the x-coordinate, you get negative 1. Now, does anyone recall in the unit circle where does that happen? I think pi. Now, may I accept it? Well, as long as it falls here, and thank goodness they placed a bracket on pi in my restriction. It says I can include it. So there's the answer. You're done. Number 3, next one, the last one I'm going to be doing. Y is equal to inverse tangent x. Now, it's interesting for the domain. On the inverse tan, if you look back in your notes there or on the handout, I think it's all real numbers. That's very interesting. You may replace x by for its domain, you find the inverse tan of anything. Now the range though, the answer coming out, put that in red so I can doing this. This, the range, I think falls between open, negative pi over 2, up to a positive pi over 2. Guys, check and see if I'm correct.
Yeah.
And there's another restriction. Let's try a few here. Let's try first, maybe try to find inverse tan. 1. Translation. There's an angle out there that when you find its tan, you get 1. Now, does anyone think they know? I know tan is y over x. Does anyone know where on that unit circle, if you place the y coordinate over the x coordinate, you're guaranteed to get a 1 marker. Okay, I'll go quadrants first. Okay, quadrants, tan is 1, positive 1. In quadrant 1, in quadrant 3. Guys, are those the 2 quadrants where tan is positive? Now, can you tell me the number? 5 or 4. Now, that's in quadrant 1. If, I don't know yet, quadrant 3, if you check out the unit circle in quadrant 3, I think it's helped me out here, 5 pi over 4?
Yeah.
I did it quickly. Now, which of those 2, if any, can I accept? Or you have to accept the one that falls between these 2. And it is pi over 4, 45 degrees. So after all that thought, final answer here is only pi over 4, not 5 pi over 4. 1 to 1, and you're done. That's what's going on. Okay, guys, I think I've done enough to make sure you understand there are restrictions here. I'm not doing inverse secant. Now you walk to a math 7 class, I may do inverse secant. But they'll have to remind you what the restrictions are there for inverse secant. It's in your textbook. Inverse cosecant, restrictions. Inverse cotangent, restrictions. These are the 3 primary ones. Now, Sarah, another issue before I erase and get this done. Does sine x, just y is equal to sine x, no inverse, did it have a graph? Did it have like a wave? And you were responsible for it? Cosine, just regular cosine, not inverse, did cosine have a graph? I think it started at 1 and came down. And tan had a graph. Secant, I graphed all those for you. Secant, cosecant. Is that true, guys? They all have graphs. In fact, you had a cosecant on the exam last Wednesday. Guess what? These have graphs. These have graphs. Now, I was thinking as I prepared this, should I quickly show you what the graph of inverse sine looks like? Inverse cosine looks like, because they do have graphs, inverse tan. Guys, I'm gonna go to the end and do the inverse tan first. Here we go. So what does this look like as a graph? Well, what I need to do is first remind myself what on earth the tan look like before I get the inverse. Now, does anyone recall when I did just tan? I know this one has asymptotes. Does anyone remember what I did to accept it as a parent graph?
Negative pi over 2.
Thank you. It's caught between negative pi over 2 up to pi over 2. And I think we had an asymptote here. An asymptote here. And guys, remind me, did the graph look something like this as a graph? With those asymptotes. Was that one cycle of the tan graph? Now, and the reason I'm gonna start with this, watch what's gonna happen. Now I'd like to, in red, graph its inverse. We'll graph the inverse in red. Can anyone tell me what's gonna happen? This is the easiest one to graph. They ask you to graph the inverse. Marco, talk to us.
It's gonna rotate like horizontally.
There again.
It's gonna rotate horizontally.
It could, I don't know exactly what you mean there, horizontally rotation, maybe so. Something else though, which I think will make this graph fairly easy to graph.
Maybe horizontal.
David?
Is it gonna look like a sine graph?
Not necessarily, something else.
Is
Samantha?
it gonna be horizontal asymptotes?
Thank you. If you do an inverse, inverse says interchange. Interchange the coordinates. But this is the tan graph, this is not inverse tan. If things are being interchanged, Samantha said, wait, Professor, this negative pi over 2 now, which is a vertical asymptote, now becomes a horizontal asymptote. This positive pi over 2, which is a vertical asymptote on my tan graph, now becomes a horizontal. So I can get those two out of the way quickly and say, hold on. If they want the inverse, then we'll go up to pi over 2 and drop down to negative pi over 2 and do as Samantha suggested, draw a horizontal asymptote here and a horizontal asymptote down here at negative pi over 2. Yeah. And if things are being interchanged, I see one point on the tan graph. It goes right through the origin. That's 0, 0, isn't it? David, if I ask you to form the inverse of just that one point, interchange them, does that point stay right where it is? It stays still 0, 0. So that point's also on my graph. 0, 0, flipped around, still 0, 0. So that's part of my graph I'm seeking. Now what does the graph look like? What does it look like now? I've got 0, 0, it's got me on my inverse tan graph. I've got horizontal asymptotes. I have no choice. I don't think. must it do something like this? Must it follow those asymptotes? Horizontal asymptotes, and go through 0, 0. So the red graph, I better identify this. The red graph is the inverse graph. That's a graph of inverse tan x. The blue graph, of course, is from last week. This is a graph of just tan x. Is that true? Now, please, before I do it, can someone, if we accept that graph, I'll be input here. If I accept this red graph as the graph of the inverse, can someone look at the graph itself, the red graph, and tell me what would you say based on the red graph? What is its domain?
Negative.
The red graph, is it negative infinity through positive infinity? Just based on the graph. Samantha, remind me on the handout, is that what they said should be the domain on the inverse tan?
Yeah.
Range on this, just based on the red graph, the up and down, David, I think it's caught between negative pi over 2 and positive pi over 2. And since they're asymptotes, I cannot include them. So it's open. Samantha, remind the class, was that the range of the inverse tan?
Yeah.
And there's the graph. Yes?
This may be like a dumb question, but like why, how do you know it goes like which part is above the x-axis?
Ah, beautiful, beautiful, beautiful. Hang on just 1 second here. I think there's a good way to answer this. Samantha, you're in quadrant 1 here. I think, right, is it actually quadrant 1 here on the red graph? And there's this piece down here in quadrant 3. Is that true? If I look at the quadrants, are the one piece called in quadrant 1, the other piece called in quadrant 3? Tan is positive or negative in those two quadrants?
Positive.
Positive? Now, I know what you're saying. You're saying, Professor, suppose it, and another good question here. Suppose it looked like this. I know exactly what you're saying. Can anyone give me a rationale? Why? Which makes sense. I think that's what you're saying.
Yeah.
So wait, this follows the asymptote, Professor. Goes through the origin, comes to drop down, follows the other asymptote. So why could it not have been this? Rather than what you did? Can someone tell me why?
Because it's negative. Well, in
Why would they choose what I had? Samantha, I understand your question perfectly. Yes, sir.
Seems like it doesn't change the sign, if it's positive, it stays positive.
Well, I know that now. I do know that if I chose this quadrant, quadrant 1 tan is positive, quadrant 3 tan is positive. At the same time, notice what here, negative, and then negative. For quadrant 2 and quadrant 4, tan. But why on earth, that's the first time I think I've had a student ask that in a long time, which is a beautiful question. Why on earth was it not the other way, David? Do you have a rationale?
Is that, cotangent?
Oh, maybe it's cotangent going the other way.
Yeah.
And I don't have cotangent up here. Yeah.
I was gonna say something and it might tie into the answer for
Okay.
this question.
Yeah.
But can we say that the inverse of these functions are gonna be a reflection of the y equals x line?
It does. If I draw the y's equal to x line right now, which I was going to do here shortly. It's good. If you draw the y's equal to x line, I'm just going to do it free-handed here, guys. She said, wait, Professor, I remember us doing something like this. And went through like this. It's supposed to go through here like this. Guys, could you probably identify that line as a reflecting line from the red to the blue? It looks like maybe one side is reflected through that line to get the other, to red to the blue. Y is equal to x. And why is that y equal to x there to begin with? I'm glad you brought that up, Sarah. What in the past have we done that says, why don't we draw that y is equal to x there? What does that remind you of that we've done on a quiz or an exam? If you have the correct inverse, what's supposed to happen? If you find the what, composite? Let's see if I can squeeze it in here. With respect to x, what are you supposed to get? X. And that is x, y is equal to x. That's what's drawn there, because of this right here, that we use to check. I think I call it a check. If you found the inverse, I asked you to check it, see if you got X. That's where the X came from. Samantha? I'm still thinking of a good, solid reason though.
Yeah, I still don't.
Okay? But I understand, Sarah, exactly, I understand what you're saying there. But it does fit the domain, the range on the handout.
Yeah.
The graphic itself does. Okay, guys, I think I've done enough. I think we understand what's going on. Bob, before I leave it, hang on. 80, since you're close by here, before I leave it. Let's do one more here. Inverse tan. Let's see if this may not work on the right. Radical 3. Now, I don't think directly you're going to see it on the unit circle. But Marco, when you place y over x somewhere on that unit circle, is it possible to get just a plain radical 3 coming out, y over x? If so, tell me. And I know tan is positive in quadrants 1 and 3. Anyone think they have one in quadrant 3 that if I place the y over the x, I do get radical 3? Or is it possible? From the unit circle? It's not possible? Not possible?
No, it's not possible.
Okay,
It is possible.
I would think about pi over 6 maybe. Now pi over 6, guys, remind me, have these coordinates.
No, it's positive 3.
Right? Pi over 3 in quadrant 1 had these coordinates.
Yeah, it has to. And then you.
Now which one of those two, if any? Yeah, it looks like you place y over x on this one, you place this over this, visualize in your mind, 2's will cancel, and does that leave you radical 3?
Yeah.
So there is an answer, and it is, in fact, where was I? Right here, where was this down, right here. What is that, pi over 3? Now, I will accept that if it fits this, which it does. Okay, so there was an answer. 80. 3. Inverse tan, negative 225. Let's put this in degrees this time. Nope. Thinking ahead of myself. Inverse tan of, here goes Aiden, 50. No, not degrees. That's a number. Changed it. Translation? There's an angle out there whose tan, y over x, is 50. I don't think I've ever witnessed on the unit circle. If you go all the way around the unit circle, you put the y over the x, I don't think you're going to ever get 50. Now, does it exist? Let's see if it does. Well, the domain, this is my domain right here. We said the domain somewhere back here is open on this tan, inverse tan. You may place any number you wish there. I place 50. That means, yes, there's an answer, but you can't find it using the unit circle. Mr. Park, find inverse tan 50 for me. See what it looks like.
88.85.
88.85 degrees. Like this? Like that? Okay. So it does exist. You wouldn't be able to find it. I wouldn't be able to find it unless I had some device to work with. Guys, basics. This is it. Marco and class, I'll remind you when you go to math 7. Don't tell your instructor Ranger didn't mention it. There is an inverse secant, which I didn't discuss. The inverse cosecant, I didn't discuss. And also the inverse cotangent, I didn't discuss. But the discussion will be much like what I did here, with maybe different restrictions. You guys with me? Now, Sarah, I think we'll be ready for you to read a few things from the handout. These are the class set up here. Now, as I erase, I did the graph here. I showed you what inverse tan looks like as a graph. Lisa, I did not graph myself, I placed no graph for inverse sine. Inverse sine is graph. I didn't do it. And inverse, cosine that I erased, I also had it. I didn't do it. It has a graph. I'm gonna hold off on that though. I did inverse tan only for right now. Now let me move into, I think it's part 3. Find the exact value. Of these. Sarah may need your help here. Let's see what I brought in myself first. Tons of things here. Here we go. Sarah, see if this one's on the handout. Sine of inverse cosine of 1/2.
Yeah.
Thank you. You gotta watch carefully on this. Woo! Inside there, I just did inverse cosine. A little reminder, the domain was this number has to be caught between -1 and +1. It's doable then. The answer coming out, the angle coming out, this might be one that's on the unit circle. It says inverse cosine 1/2. This much says Aiden, there's an angle out there whose cosine is 1/2. And I know and you know, you're either in quadrant 1, cosine's positive, or you're in quadrant 4.
Pi over 3.
Okay, you're saying maybe Professor try pi over 3 in quadrant 1. You guys agree that the x-coordinate of pi over 3 is 1/2? Is that true? Now, he may have lucked out, he may say, Professor, that fits right now, I see it fits. This is like what, 60 degrees? And I think by restriction, Samantha, it's supposed to fall between for cosine 0 and pi.
Yeah.
Does this fall between 0 and 180? If so, he's finished, he's done, he need not worry about this quadrant 4 at all. He's found the answer directly, it's done. Letter B.
But what about the sign?
Uh-oh, hang on. Sine of,
Pi
there you go.
Isn't that just,
There you go, pi over 3. Now that says, now it takes me into almost like a composite. Now it takes me into sine of 60. Does it take me right back into radical 3 over 2?
Yeah, radical theory.
Does it? Is it radical 3 over 2? And there's the final answer for this. That was the original question. Letter B. Sarah, please follow along with me and see if I'm using the same ones. Next one looks like this, guys. Secant inverse tan radical 3.
Yeah.
Now maybe, I don't know yet, but this means there's an angle out there that when you take its tangent, you get radical 3, positive radical 3. And tan is positive in quadrant 1, quadrant 3. Hey guys, this one's tricky. Does anyone think they know maybe in either one of those quadrants, if you place the y over the x, you get merely radical 3, and I may have had a radical 3 somewhere in my work tonight.
Pi over 3.
Wait, how much was it?
5.
Pi over 3. Okay, so we think the answer here is in quadrant 1, we think it's pi over 3, 60 degrees. If so, now this says take secant of that. And guys, pi over 3, I think has for coordinates, help me out here, is that 1/2?
1/2 of 3?
Radical 3 over 2, absolutely. And if they want secant, I know secant should be what? 1 over cosine of 1 over x, 1 over 1/2, turns it into 2. That's the type of thing you gotta do. It'll make all kinds of sense here. Now letter C. Sarah, did I have that one on the handout?
Yeah.
Oh, wow, we're working on the handout then. The next one looks like this. I think I put things in here a little bit. Oh, this one coming up, here goes. Tan inverse sine 1/3. Translation. There's an angle out there, I'm gonna take its sine, I get 1/3. Restriction for sine, where is that angle located? It's gotta be either in quadrant 1, that's where sine is positive, quadrant 3. Oh, not quadrant 2, not tangent. It's gotta be in one of those two quadrants for sine to be positive 1/3. Is that true? At this point? Now, David, have you seen 1/3? Have we worked with 1/3 on the unit circle? You've never seen 1/3. You've seen a 1/2, radical 2/2, radical 3/2, those types of numbers. You've never seen a 1/3. So we've got some issues. Now, first, does it exist, or is Randy set one up that has no solution? But this number right here inside here for inverse sine, in my discussion for inverse sine, it's got to fall between -1 and +1. That's its domain. Does 1/3 fall between -1 and +1? That's saying it does exist. Now find it. And I'm not going to ask Park to do anything with it right now. We got to do some thinking here. Now, I love these types of problems. You'll see some of these for sure in the final. So finally, A, we ran to 1. We cannot directly go to the unit circle. It's not there. Rather than asking Park to use his device over there, no, we're going to figure this one out. Samantha, go for it.
Can you use an identity?
Beautiful. Beautiful. Now, she said, wait, Professor, if I can't find it, can I jump into those 8, I think it's 8 identities, and try to use one of those to get me a start and finally lead me to the answer? Samantha, in terms of identities, did you have one in mind?
I mean, the first one that like naturally just came to mind was the.
I mean, which one?
It was the sine squared
Got you,
data,
hang on.
but like, you don't necessarily have tan or cosine, so.
Well, hang on a second, because I think right there, that's one that most students think of as an identity, sine squared plus cosine squared is equal to 1, Lisa, hang on. Do I know what sine is at this point? Sine's 1/3.
Yeah.
So I can put that in right now. Into that identity, it got squared.
Okay.
You still got this. She gave me an excellent choice here. Equal to 1, this is 1/9. You gotta remove that 1/9 over by subtracting, I think you get 8/9. Take a square root, now here's where it's gonna get tricky. I know it's plus or minus. And looks like maybe a 2 radical 2 over what, 3? That's for cosine. Whew, hang on just a second. Okay, so we've got that. Guys, now which quadrants are we in? Inverse sine restriction was, help me out, you gotta be caught between -pi/2 and +pi/2. Is that true? So -pi/2 to +pi/2 by definition by the restriction, guys, that's like saying, Professor, if I'm caught between -pi/2 and +pi/2, here's +pi/2, here's -pi/2, am I caught in that? By restriction. So I'm caught between -90 and +90, that's either quadrant 1 or quadrant 4. Okay, so now I know, look at all this thing get out here. I'm looking for quadrant 4 or quadrant 1, quadrant 4. Guys, I gotta think about what's going on here. Cosine is equal to plus or minus. Are we in,
Quadrant 1.
you think we're in quadrant 1?
Yeah.
If we are, which is the easiest quadrant ever, it's gonna be positive. Is that true?
Yeah.
Jeez. Now, if that's true, and by the way, sine was positive also. So now I got cosine with Samantha's help. Now, what they want though is tangent of this. Wow. Do we have enough to find tangent?
Yeah.
Yeah, tangent is what? Sine over cosine. So on the side here, to conclude this, if they want tangent, which they do, sine was 1/3. Cosine is at 2 radical 2 over 3. We just found that. You know the 3's will cancel. Rationalize this. Do I finally end up with radical 2 over 4? Yes or no? And there's the answer. Well, I see she looks now, I'll just get a little harder. Hang on just 1 second, let me ask Mr. Park first, and I'll take some questions. Mr. Park, can you help me out? Let's go back to the original with your device here. Find what it says for inverse sine 1/3.
19 point.
19.4. That's in degrees. Now, would you please take tan of that 19.4? And see what that's close to.
0.35.
0.35. Hard. That's by calculator or device you're using. I got this. Would you please now give me an estimate, approximate, what is radical 2 over 4 close to?
0.35.
They agree. They agree. Now, it's also hands on it though. Sarah,
So I have a question.
go ahead.
So when we did, sine, cosine, the inverse cosine of 1/2, we said that cosine, it's like saying cosine is equal to 1/2, and then and then what was in between the restrictions, and that was pi over 3. But for when we're finding the tan, with sine inverse of 1/3, we also said, well, what's the restriction of when sine theta is 1/3, and we didn't find, there was no, well, there's no place in the unit like we didn't identify the exact place in the unit circle, but we still went along with the Pythagorean identity.
Yes.
So,
Now, I see exactly where you're going. Let's say, for example, you're a student and you had, for some reason in your mind, you had a negative 1/3 here. And David, when you put this in here, when you square it, you still get 1/9. So even though you may have made a little mistake in looking at the restrictions there, you put a negative 1/3, it should have been a positive 1/3. And when you go into that sine squared plus cosine squared is equal to 1, it still gives you the answer. Let me do this for you, Sarah. I think I understand what you're saying here. Inverse sine has, this is the restriction. So the angle I'm looking for must be caught between negative 90 and a positive 90. And I think we finally decided upon, I think he gave me 19.4 degrees. That's in quadrant 1, or it should be. So I'm gonna look at this first, right here, quickly, and go from there.
but why? But I understand why, but in the other ones, we, connected them with like pi over 3 or with some sort of, like unit circle.
And this one, exactly, and the reason on this particular one is, this is not on the unit circle.
Yeah, sorry.
That's the problem with this one.
Okay. So, okay.
Marco?
I think I can explain it. It's because the sine 1/3, the 1/3 is positive, and you're looking at between pi over 2 to negative pi over 2. The bottom part is going to be sine is negative.
Beautiful. Down here, sine is negative. That's ruled out then for us. So the angle that we're looking for, which we cannot name directly, is this one. But Park found it for me. He says it's 19.4, which is in quadrant 1. So I'm thinking in quadrant 1, which is the best quadrant ever to be in, because everything's positive. Okay, now let me do this for you. Does that sort of help?
Yeah.
Because I got another option here,
Okay.
which some students like. Let's do a visual of what's going on here. It says sine is equal to 1/3. Let's see if we can do this. And let's say, with that, we have this. Sine is equal to 1/3. So David, I'm gonna do this. I'm gonna make a sketch. I'm gonna be in quadrant 1. That's where sine is positive. And I'm gonna say, well, why not consider this? Let's see if this will make sense for us. Drop a perpendicular, we'll form a right triangle. And when I form that right triangle, let's see if this black marker will work for me. I'm gonna have this. Watch carefully. Watch carefully. We're doing visual. At this point, what do I know on that right triangle? I know the y. Sine. Sine is how much? 1/3. I'm gonna quickly go to this side and say, here, let's place a 1/3 here. I get this real quick. 1/3 there. The hypotenuse, I hope with what we've done so far, sometimes it changes, I would hope, Aiden, that that is on the unit circle, therefore that might be a what? The red. Red might be a 1. Do I now have enough of that little bit of thinking to find the missing side, the base? You know, c squared is equal to what? A squared plus b squared. So if I, on the side, did this is just a visual what's going on here. C squared is 1 squared. A, let's call this side down here, A is missing. B is 1/3. Guys, you're going to end up with 1 is equal to A squared plus 1/9, which is beautiful. Try to solve for A, move the 1/9 over, subtract it, you get 8/9. Do a square root. And that goes down here. True, by Pythagorean theorem. And what were they asked me to do after all this business? Express the tan. And how would I find the tan on the right triangle? What, place y over x? And I know what the y is, it's this side here. So if I place this over this, does that lead me right back into what we were doing here? If I do it visually. Guys, that help visually? Sometimes the visual there will be a little bit better than the definition or what we're using there. Okay. Sophia, let me get Sophia. Sophia, have a question.
So basically, the reason why cosine is positive is because sine is positive.
On this one, sine, we said by restriction, I got the call between negative pi over 2 and a positive pi over 2 for inverse sine. Okay, so that means I'm here or here. In quadrant 1 or quadrant 4. Down in quadrant 4, though, sine is negative. And I got a what? A positive 1/3. That restricts me down to, of those 2 quadrants, I'm in quadrant 1. Because of that positive 1/3. If it had been negative 1/3, good question, I'd be down here in quadrant 4.
Okay, yeah.
Which I think that's one coming up with something like that. Samantha.
So we always use the restriction with the value inside.
There you go, you've got to use the restriction, I'm gonna start doing it in my discussion. I will quickly point out what that restriction is as soon as I see this. I gotta point out by restriction, where am I, and then go from there. Okay, guys, we finished up, that help? Sarah, the visual,
Clarify something with your visual?
the visual help some?
Yeah, it helps.
Okay, okay. There we go. Do one more here, guys, and see how close to the break we are. Not too fast. Was this one, by the way, on the handout? It was, wasn't
Yeah, it was on the handout.
Okay, hang on.
That's the third one.
Now, is there one with a cosecant? Check and see if I'm correct here.
Yeah.
Cosecant inverse tan what?
-2.
A -2?
Yeah.
Okay, here we go. Squeeze in right here, letter D. Sarah, depends on you, now read this for me. It's cosecant inverse
Inverse tan of -2.
-2. Okay, let's do a good job of this. Then we'll take a break. And then we'll do it both ways, visual and also maybe identities. Guys, unless someone thinks they know from the unit circle, when you place y over x, you get -2. That's the best case ever. Is there a place on the unit circle, if you place a y over the x, you get a -2? I don't think there is. Of all those on the unit circle, I don't think they even work. Do they? You give me a -2? Y over x, y over x.
Negative pi over 3?
No, you're probably thinking about maybe a cosine or a secant. I'm looking for this, this says there's an angle out there whose tangent David, it says tangent is equal to a -2. If it's on there, I'll take it, that'll save me some work. Guys, is it on the unit circle? If you place y or x anywhere on the unit circle, you get -2? I don't think it is. It will require a little bit of work. Hang on, Marco. Now, I'm gonna do this for you. Samantha brought this up. Quickly, immediately, I better point out where I am. An inverse tan has a restriction, guys. The angle has to be caught between what? -pi/2, got those restrictions, and +pi/2. Now that to me is quadrant 1, quadrant 4. This is going to be much better. Quadrant 1, quadrant 4. My restrictions got to be placed there. I noticed they gave me here inside here, which is like domain. This is -2. Now think for inverse tan, the domain, the x is open. It's -infinity through +infinity. So -2 is fine. But my angle coming out the range, the output, it's got to fall here or here. David? They said tan is -2. Well, where is tan negative? Quadrant 1 or quadrant 4? I'm in quadrant 4. That's where tan is negative. So if I start sketching here shortly, I know I'm in quadrant 4. So this is where I will be located if I need some help. The angle's in quadrant 4. Now, does anyone, let's do this by identities first if we can. Guys, I'm looking for cosecant. I know what tan is. Tan is -2. Can anyone make a connection to any identity where you know tan is -2? And either the first one in my mind would be 1 plus tan squared is equal to secant squared. That's the first one that comes to my mind. And in essence, though, we're looking for cosecant. But I could actually use it. Does anyone have an idea how to use maybe an identity, maybe 2 or 3 identities to finally get me there? Samantha, help us out.
Can't you technically do like 1 over cotangent squared equals secant? Oh wait, no.
Nope.
That's the right.
Nope.
Well, use the one that you use, and then, once you have.
Then use another one.
Yeah, use another.
Okay, hang on, Marco. So the one I had in mind was this one, put it in red. That 1 plus, was it 1 plus tan squared, guys?
Yeah, it's secant squared.
There you go, it's equal to secant squared. You gotta know your identities. Aiden, as I place this here, you say, Professor, I guess you're looking for cosecant. Why do you put secant? I'm trying to find a way out, okay? They gave me tangent as -2. I can put that in, right, Marco?
Yes.
-2 goes here. That's what, 5, I guess? Nice. So far, so good? Take a square root. Now, this point's plus or minus, I'll decide it's going to be plus or the minus. As plus or minus, radical 5 is equal to secant. I know this is not the answer, but all this is true. Guys, I'm in quadrant 4.
Let's be positive.
Positive, thank goodness. So we'll erase this negative sign. So that, with Marco's help, 100% you get partial credit. It's not the answer, but as a start maybe. Now I know what secant is.
1 over.
I'm looking for a cosecant. All right, here's what I'm looking for. I'm not there yet. Now, does anyone have an idea of what to do from there? Marco?
Well, you can do 2 more properties.
Like what?
So now you can find what
Cosine?
cosine is.
Okay, let's see if I can. Hang on now. Like what you want to use? Secant's equal to 1 over cosine?
Yeah.
Okay, hang on, I'm gonna use it. He said, wait, Professor, there's another identity that says this, if it'll help. If it'll help. So that means cosine, that comes down to this. Cosine could also be represented as 1 over secant. I saw some students write like this on your exam, which is fine. It says merely go over here and take the reciprocal of this, and you get cosine. So cosine in no time at all will be 1 over radical 5 rationalized. Oh, this is a nice problem. You got that. Darn it, we don't have that. All that's true on the board. Woo. Now, is there another identity? If I insist that you use identities, is there another identity that you can now follow and maybe take me eventually to cosecant? Sarah, you got something in mind?
Can't you do, one,
Well, isn't, well, oh yeah, yeah, that's what I did. I found sine with cosine.
Sine squared plus cosine squared is equal to 1.
Yeah.
Hang on. Marco, 1, 2. Now she says, now try this. Another identity. And we're gonna close now with this, guys. Take a break here. We need a break after all this. She says, Professor, well, I know what cosine is. Cosine is this right here, right? So she's gonna put
Yes.
that in to this. That's radical 5 over 5, it's been squared. A little math to do, but that's what it means to do. This is sine squared. Guys, we're gonna do this. If I square this, I think you end up with 5 over 25.
yes.
1/5.
Yeah,
Move that over. 1 subtract 1/5,
4/5.
4/5. Save me a little time here. Now take a square root.
2 over, oh, that would be like
Hang on.
rationalized.
I'm not there yet. Let's do a square root. And guys, right now I see a 2 over radical 5.
Yeah,
And then Lisa says, no, Professor, rationalize that.
2 root 5 over 5.
Beautiful, thank you, Lisa.
Negative.
There's sine. Now, I gotta keep in mind, man, look at all this you got to do. We're in quadrant 4.
Negative.
It's negative. I'm in quadrant 4.
1 over that.
Look at all the work here. And now I'm looking for cosecant. Do we now have enough to find cosecant?
Yeah, so
Finally, number 4 identity. Cosecant is equivalent to what? 1 over
sine.
sine. In other words, the reciprocal of this. Just flip it over. Negative, 5 over 2 radical 5. I make a mistake here. Rationalize 5 radical 5 over what is that, 10? And finally reduce this down to, help me, is it that? Lower. I did all through identities. Marco, you helped me out here. Sarah stepped in, helped me out here. Final answer, here it is, this is a problem. A negative radical 5 over 2. I took all that work. Hang on, Marco. Now, let me say that visually. Then I'll take your question. Guys, visually. On your worksheet coming up, make for a little extra credit for points, a few points, not many, a few. Or on the final exam for sure. If I say use identities, you gotta use identities. If I don't say how to do it, you may say, wait, Professor, I'm a visual type person. I'm just visualize what's going on here and try to get the answer. Let's do the visual part here. And then we'll take a break here so we get the same answer. Guys, go back to the beginning. Tan is -2, and we're in quadrant 4. David, if I sketch this, I'm in quadrant 4. Down here. We're dropping perpendicular. To the x-axis, is always to the x-axis, and form this, a small right triangle. Lisa, I know tan is -2. I gotta be careful here. I know tan is y over x. Now be very careful before we take a break here. Can anyone in this clever class tell me any way at all to label, those side here are hard to see, on that right triangle, any sides to label, so you're guaranteed when you put the y over the x, you get -2. I don't care what numbers you use, as long as you get -2. Place of y over x, which side is which, give me a number. This is interesting before we take a break. All right, close it out, yes.
-1
Oh, get close, that might work out, it's a little awkward with 1/2.
I mean, 1/2, and then, negative. Negative 1 on top, and then 1/2.
We're getting close. I think I follow you, 1/1/2, which is 2.
Yeah.
Yeah. Y over X, by the way, guys, is this the Y here? Is this acting as the Y?
Yeah,
Is this the X?
yeah.
And of course, we've got a hypotenuse. Could I do it like this so we won't waste break here? Is that Y over X? Is that -2? That's tangent. Now, but what the problem is that if you find the hypotenuse, C squared is equal to A squared plus B squared, can someone tell me what that is right quickly? What is that if you go ahead and get away from Professor, one side's missing, the hypotenuse?
25.
I think I heard it. C squared is equal to 1 squared plus -2 squared. I'll put the next sign in there. It is 5. So C, the hypotenuse, is radical 5. Now watch carefully. I know I'm taking some of your break time, but you will get your break, of course. Is that a visual of what's going on? What's the only issue? Everything's perfect visually. What's the issue right now? Let me remind you.
The restrictions.
And then something else. What, right now, and I will modify it quickly, there's an issue right now with what we're accustomed to. If I draw a circle around there, what is it that bothers me? Yes, it's not a unit circle. The radius should be 1.
Oh, yeah.
And therefore I can just read the answers off directly and make it a unit circle. A is not gonna make this a unit circle quickly. If I do this, I'm gonna change this to a 1. So it will be a unit circle. How? I'm gonna divide this by radical 5.
All of the.
That means
values.
that has to be divided by radical 5. This 1 has to be divided by radical 5. Now it's a unit circle.
Oh.
I've changed it to something we accept. Now, if it's a unit circle, and finally they're asking me for cosecant, I think it wasn't it cosecant? Cosecant should be 1 over y. That means find the reciprocal, I guess, of that. Is that true, guys? Flip it over, and would that take me down to where on earth were we for a final answer here? Will that take me there?
Yeah.
This right here, just flip that over. What was it? Radical 5 over 2, reciprocal, negative of course. Does that take me directly to that answer? Whoa. Sarah.
If we didn't want to make, hypotenuse 1, can we also say, well, sine is equal to opposite?
Oh, see, that's chapter 7.
Oh, okay.
That's why I stayed away from opposite hypotenuse, adjacent hypotenuse. And what's that word you guys use back in? Sokotoa, I thought they were calling me a name one day, I had never heard that. Oh, Professor, Sokotoa. I go, whoa. They can call me a name? I've never heard that before. Now, that comes up in chapter 7. And then it'll open up when you use it.
Okay.
Yeah.
So, we get cosecant by dividing the square root of 5 by negative.
Yeah, it should be, cosecant by definition is 1 over sine.
Yeah.
Here's sine. Why? There's a sine right here. So just flip it over.
But is it the same as like square root of 5 divided by negative 2?
Well, it's radical 5 divided by 2, negative, and that takes me to the answer we got earlier about using identities. It's the same answer. Now, right now, I think, guys, before we take a break, I think, would you guys give me some input real quickly, just an answer, you know, don't put anything else out. David, if you're seeing this on the exam or a worksheet, would you prefer to do it visually and do a triangle and figure it out by using a triangle? Or would you jump into, and it took Marco's help, Sarah's help, it took maybe four identities here to get to the answer. Would you prefer to use identities?
Yeah.
See, that's what I thought. I show the visual every time students know, they go back to the idea, which I love. I love using the identity. But if you should visually, you're more of a visual person, you wanna draw a sketch and do it. I'll do it, unless I insist you use it, I didn't. Guys, how's all this look? Okay. We got, about 10 minutes for a break, so please take a break.